All right, in this video, we're going to go and do some more molarity practice problems to make sure we're pros before we move on to our next concept. So let's go ahead to this next example here. We have determined the concentration of a solution of sodium chloride if 1 mole is dissolved in 500 mils of aqueous solution. So this one's not too bad. It's actually a pretty straightforward one, but there is a common error that students often make here. So let's do our concentration is equal to N over V. We have our number of moles already. Perfect, 1.5 moles. That's 2 sig figs, but our volume, notice, is given to us as 1 sig fig. And the other problem is that the other thing is that it's in milliliters. So we do have to make sure that it becomes liters. And so that's 1 sig fig there. 500 mils is 1 sig fig, and we're going to keep it at that. So we planned it all out. Now let's go ahead and write it out here. So C is equal to N over V, which is equal to 1.5 moles over 0.5 liters, which will give us essentially, it's like doing times 2, but it'll give us 3. So that'll give us 3 moles per liter, and it's to 1 sig fig. So it's already one significant figure. I don't think I need that much space to do that. I don't think there was any, no error there, nothing. Yeah, no, it's as simple as we think. Then you can write your therefore statement. So therefore, the concentration of the sodium chloride solution is approximately 3 moles per liter, or you can write it or 3 molar, like that. That's another way you can do it. All right, let's go ahead. Well, let's first of all check if we're right with that. Let's go look at our answer key, the partially filled in part. That's right, 3 moles per liter. All right, let's go on to our next example. Determine the volume of a 0.35 molar or mole per liter solution that contains 0.5 moles of solute. Okay, so let's write this out here. So 1 C is equal to N over V. We want to find the volume. So we want to isolate for volume. So we're going to basically multiply and then divide. So we're going to have volume is equal to N over C. So volume is equal to N over C. Be careful with that. Make sure you do this part. This is probably the most important part. Don't do this too quickly. You want to make sure that formula is right. Okay, so essentially I just sent the volume to the top there and then the concentration to the bottom. So they basically switch spots. So V is equal to N over C. And we have information given to us. We have our concentration and we have our moles. So let's go ahead and write that out. So V is equal to N over C, which is equal to 0.50 moles of whatever the solute is over 0.35 moles per liter. Cancel moles out. We're left with liters and they go on top. And so we'll get 0.5 divided by 0.35. And we get 1.428571429 liters. Remember that we do end up with liters because the molarity is always in moles per liter. But we have it to 2 sig figs, so that's approximately 1.43 liters. And if you had to convert it to milliliters, you just multiply by 1,000, or approximately 1,430 milliliters. Here you weren't asked you weren't told what unit, but you would get it by default in liters. And if you were asked in milliliters, you could multiply by 1,000. Now let's see if that was right. Did I make a mistake there? Oh, right. I had to do 2 sig figs. I put 3 sig figs. So there, see, sometimes I make a mistake without even, and that's why it's important to check those answer keys. So we said 2 sig figs. So 1.4 is our answer because that's right, 2 sig figs, not 3. And we get 1,400 milliliters. There you go. That's better. All right. Let's move on to our next question. And you can see the answer for this one is listed in brackets there. So we did a good job there. All right. So our next example, determine the mass of sodium chloride required to make 500 mils of a 0.45 molar solution. So this is similar to the example that we saw over here. Very similar. we're looking for the mass. So remember that we have our concentration given to us. That's our molar concentration in moles per liter. And we have our volume given to us as well. So it's volume, this is concentration. So step one here, remember that concentration is equal to N over V. We're looking for mass, so we can't find that, but we can find the moles. N is equal to C times V. And we know that once we have moles, we can do the mass is equal to moles times the molar mass of this sodium chloride. So let's go ahead and do that. So our moles is equal to C times V, which is equal to, we got to be careful. Let's write this out here. So before I forget, C is equal to 0.45 molar. And then V is equal to 500 milliliters, which is equal to 0.500 liters, because there's 3 sig figs there. Okay. Now, at the end, though, our answer will be in 2 sig figs, just because that's our smallest number in the question. So let's do our our concentration, which is 0.45 moles per liter, multiplied by the 0.500 liters. Cancel out liters, and we get our moles. So we have 0.45 times 0.5, and we get 0.225 moles. And so our step 3 is to do our mass is equal to moles times molar mass. And just a reminder, so our molar mass of NaCl is 22.99 plus 35.45, and we get 58.44 grams per mole. So it's going to be 0.225 moles times 58.44 grams per mole. Cancel out the moles there, and we're left with grams, and so we get times 0.225. We get about 13.149 grams, but that has to be to 2 sig figs, so approximately 13 grams. And we can write a therefore statement. Therefore, approximately 13 grams of sodium chloride are required. And so again, this would be a practical example in the lab. I could say, okay, for this lab, I need the students to make 0.5 molar solution of sodium chloride, 500 mils of it. So you would go, figure out the mass needed, 13 grams, weigh that out, put it into a 500 mil volumetric flask, add your distilled water, shake to make sure it's dissolved, then continue adding distilled until that meniscus reaches the etched line of the 500 mil volumetric flask. And let's do our last example here. If 45 grams of calcium hydroxide is placed in a 1 liter volumetric flask and it is filled with water, what is the solution's molar concentration? So not too difficult, but you do have to make sure you don't make common errors. So number 1, concentration is equal to N over V. We don't have concentration, but we do have the mass, 45 grams. We do have our volume, 1.0 liters. It looks like we're going to have 2 sig figs at the end here because that's what we have for both numbers. Now we need to find the number of moles first because we need that for our concentration. So remember that the mass is equal to moles times molar mass. So the moles is equal to mass over molar mass, which is going to be equal to 45 grams over the molar mass of calcium hydroxide. So make sure it's calculated properly. Calcium is 40.08, and then we have 32 for oxygen and 2.02 for hydrogen because there's 2 of each. So 74.1 grams per mole. So 74.1 grams per mole over here. Cross out the grams, and we get, so 45 divided by that answer, 0.607287449 moles of the calcium hydroxide. Now we want to find the molar concentration. So Our step 3 is going to be to do our C is equal to N over V, which is 0.607 moles. All the digits are still in my calculator. I'm keeping them in there. Divided by the 1.0 liters. And so it'll give us 0.607287449 moles per liter to 2 sig figs. That's approximately, that's a 0 there, 0.61 moles per liter. So therefore, the concentration of the calcium hydroxide solution is approximately 0.61 molar or moles per liter. Let's go and take a look to see if we got the correct answer. It looks like we did. Perfect. So in the next video, we're going to do a problem that's a bit more of a challenging problem. It's still the same concepts, but it does add in a layer of complexity because we also talk about 24% mass embedded within there as well, and we have density added, so it's a bit more of a complex problem, and I'll show you a few methods to solve that problem. But right now, you've done all the basics for molar concentration calculations. Make sure you know how to sketch and know how to explain how to make a solution using the solid method, the weighing method. Watch that video. It's a really great video. Go over the formulas carefully. Don't make mistakes. The most common mistakes I see is with rearrangement, so make sure you know how to rearrange these equations or formulas to get formulas for what you are looking for in the question.